about this again. We've got our balanced reaction, okay? How did you decide that aluminum hydroxide was the precipitate? Summer, tell me. Okay. Okay. So, because this one has a 1A element in there, you know it has to be soluble. It has to be soluble, okay? So, you really don't have to know the hydroxides. But, do you guys know about the solubility of hydroxides in another way? Okay, they're often very insoluble. Besides being an ionic compound, how else could you classify a hydroxide? It's a base. And haven't I asked you guys to memorize the strong bases?
Yes.
Yes. And tell me, by definition, what does a strong base do? It dissociates completely. So is it soluble?
No.
Yeah.
Isn't that what solubility is? It dissociates completely. So the things that dissociate completely, the things that we break up in net ionic equations, are strong acids, strong bases, and soluble ionic compounds, right? Soluble salts. So the fact is that the strong bases, because they're hydroxides, will also be the soluble hydroxides, okay? Who remembers, just a real quick side quiz, okay? Who remembers what hydroxides, or what the strong bases? Who can give me part of the list? Danny?
Is that like, it's like 1A's and then heavy 2A's?
Okay, so all the 1A's, so lithium, sodium, potassium, rubidium, cesium, and I guess even francium, all of these hydroxides, those are the 1A's, okay? And then she mentioned there's some 2A's. Pyong, did you have a more definite list?
I was going to say what she said.
Okay.
The heavier 2A's.
So the heavier 2A's. Where do we think we start? Does anybody remember?
Calcium.
We start at calcium. Right. So calcium hydroxide, barium hydroxide, and strontium. Those ones are soluble. Okay, I imagine radium hydroxide would be too, we just don't use it too much, okay? So these are the strong bases. Because they dissociate 100%, those would also be the soluble hydroxides. Does this make the list? No. So that's another way to tell, okay? But I love how Summer just simply said, this has got a 1A, done. Okay? If you form a precipitate, you know one has to be solid. Okay? So as long as you rule out the other one, you're good to go. Okay? All right. So the first question says if you have 20 milliliters of each one, okay? You have 20 milliliters of lithium hydroxide, 20 milliliters of aluminum chloride, and each of them are 1 molar, which would be the limiting reactant. Okay? Paula, what's the very first thing that we should calculate? Not even looking at your paper, just in general. How do we start problems like this? What do we always go for first? Moles. We go to moles, right? We're given molarity, we're given volume, just like if some problems we're given grams or we're given particles, but we always want to get to moles quick. What's a quick way to get to moles from molarity and volume?
Moles over liter.
Okay, moles over liter. Is that what you're going to say, Michaela? Molarity times liters is moles. Absolutely, because molarity is moles per liter. So, if we converted this to liters, 20 mils is how many liters? 0.02. We're going to move the decimal over 3 times. So 0.02 liters and 0.02 liters. Everybody with me? All right. And now, because I gave you an easy molarity, we can do this in our head. How many moles of lithium hydroxide do we have? 0.02. Okay. And how about the aluminum chloride? The same. So, and I made it simple on purpose so that we could focus on the concepts, not get bogged down by the numbers. Okay. Now, this is the same as if you would have done 20 milliliters of, let's say, lithium hydroxide and then used a bridge and said, okay, if it's 1 molar, then that means there's 1 mole per 1,000 milliliters. How many of you use this bridge? Okay, and some of you might have kept on going, but if you stop it right here, won't you get 0.02 moles of lithium hydroxide? You guys see that? It's the exact same calculation. This is volume. You just kept it in milliliters. This is molarity. Okay, so it's the same thing. Okay, now let's see if you guys can do this in your head. By just looking at these numbers, can you tell which one of these is going to be limiting?
Yes.
Okay, who would like to tell me why? Which one? Star?
The lithium hydroxide.
Okay, the lithium hydroxide. And if you, how could you explain why?
Well, it says that you need 3 times as much lithium hydroxide, and if you have the same amount of each, you're going to run out of lithium hydroxide.
Absolutely. This balanced equation says you need more lithium hydroxide, 3 times as much as this, yet you have the same amount. So clearly you don't have enough of this. Does that make sense? Okay. You could actually not do any more calculations and just write that sentence down as your answer to the first one. That would be fine. Okay? Did you do that?
No, I didn't.
Okay? I don't tend to do that either. But because these numbers are very simple, and you can say you're given the same amount, yet you need more of one and you don't have it, it would be limiting. This is how I would do the calculations for it. Okay? But no matter what, whether we do calculations or do a sentence, we have to make sure that we have justified the answer. That we're not just spitting out numbers and say, oh, and therefore this. Okay? You've got to connect the dots. You've got to connect the answers to your calculations to your reasoning. Does that make sense? So let me show you how. Here's one thing that I do. I start with 0.02 moles of lithium hydroxide. I just start with one of the 2 chemicals. And using the ratio, every 3 moles of lithium hydroxide will need 1 mole of aluminum chloride. And to kind of use the same modeling that I did yesterday, I'm going to put the word given here, right? Isn't that what's actually given to me? Okay? And this is what I need, right? So, when I get the answer here, isn't this 0.0067 moles of aluminum chloride needed? And so now, I'm going to look at what I actually have. This stuff is what you have, or what you are given. Same with this. This is what we had, or what we were given. Okay? So, we have given, we have 0.02 moles of aluminum chloride. We just calculated that what we need is 0.0067 moles of aluminum chloride. Which one's bigger?
The given.
The given. If we have more than we need, then what can we conclude about aluminum
It's
chloride?
excess.
It's excess, okay? Because we have more aluminum chloride than we need, aluminum chloride is excess reactant. Okay? How many of you need to add a little sentence to what you did as your calculation? To justify it, to truly justify it. Okay, you have to make sure that you're not making the grader, whether it's me or whether it's the College Board, make the leap for you. You got to tie it together. Okay? Here's one way you can do it. Did anybody start with the aluminum chloride and solve for the lithium hydroxide that you needed? Does anybody want me to do that? It doesn't matter which one you do. No? You don't need me to do it?
Wait, do what?
Start with this one and calculate this. Yeah, it's just another way. Guys, if you started with 0.02 moles of aluminum chloride, how many moles of lithium hydroxide would you need?
0.6.
You would need 0.06. You need 0.06, you have 0.02, do you have enough? No. Which was kind of what we said in the very beginning. We kind of did that in our head. That was easy to do in our head, wasn't it? Okay? Does anybody need me to do it the way you did it in Chem 1, where you started with each amount and went all the way to product? Who needs me to show you that way? Don't be shy. I mean, it's a valid way to do it. Anybody want me to do it that way?
Show me.
Do you really want me to?
Sure.
Or you just say that?
No, you can show
Okay.
me.
All right. The one thing is, you can't just say this is a smaller amount, therefore you have to connect it again. So here we go. We can start with, are you guys okay if I start with the 0.02 moles? Okay. So we start with 0.02 moles of lithium hydroxide. According to the equation, 3 moles of lithium hydroxide will make 1 mole of aluminum hydroxide. And I'm not going to go to grams because the question never asks me to. So I'm trying to keep my math as simple as possible. 0.02 divided by 3 is 0.0067 moles of aluminum hydroxide. Okay? Here, if you start with 0.02 moles of aluminum chloride, every 1 mole of aluminum chloride makes 1 mole of aluminum hydroxide. So, 0.02 moles of aluminum hydroxide can be made. Okay? Which answer would you pick? You'd pay attention to the smaller one, and what would it tell you? It tells you that this is limiting. But, how do you explain how you knew that the smaller answer would indicate the limiting reactant? That's the challenge. And that's probably what we haven't had to do before. Who could tell me why?
Because
Lower product yield.
Okay, keep going. The lower product yield tells you what?
But it won't as much.
but like given this.
Okay, and why won't it make as much?
It was all used up.
Ah, you guys are doing good. It's kind of like a round robin, okay? The smaller amount, this amount is when this gets used up, right? This amount is when this gets used up. But obviously, this one's going to run out first. Did y'all see that? Okay, so you're going to have to, it's hard to write that down on paper. A lot of times we just say, you know what I mean? And we all go, uh-huh, okay? But we've got to kind of verbalize that, okay? So, this amount, and we make sure that door gets closed. Okay, this amount
Oh.
is produced when LiOH reacts completely. Does that make sense to you guys? Or in other words, runs out. And because 0.0067 moles is less than 0.02 moles, the LiOH runs out. This might be a little wordy.
Yeah.
Sometimes I have a hard time, I mean, I can explain it, but sometimes it's a little wordy. The LiOH runs out before the aluminum chloride. Therefore, LiOH is the limiting reactant.
If we can justify it, like, with math, do we have to write this in it?
Yes,
Still write this in it?
yeah. We did justify it with math. You see what I mean? Except for, we're doing something in our head, Michaela, to know, pick the lower answer, and that's limiting reactant. And really, that's a trick. Well, I don't know if it's necessarily a trick, but that's how we were told in Chem 1. Well, in Chem 1, when we first did that, we said all this. But then when we got down to doing, you know, the practice problems over and over and over, we would just circle the lower answer, pick the limiting reactant, and move on. We stopped expressing why. You know what I mean? But probably your teacher, when you first did it, had to explain to you why picking the lower answer was a good idea, why that did anything. That's what we can't lose here, okay? Even this way, Michaela, see, we articulated it here. You have more than you need, okay? You can do it very succinctly. If you can practice and get it succinct, that's fine. But you gotta kind of have to put down the logic in your head on the paper, okay? All right. Does everybody feel comfortable that we've identified the limiting reactant?
Yes.
Alexander, did you have a question? No. Okay. All right. So now we're ready to move on to the concentration of the lithium, right? Do you see that all the rest of the questions focuses on ions?
Yeah.
Did anybody end up writing a net ionic equation, even though I didn't ask you to write one? Did anybody end up doing it? Yeah, because that's kind of how we think in ions. Okay, so I'm actually going to erase. Can I erase what we have?
Yeah.
Who's still copying? Anybody?
Can you read this statement up?
Leave this statement up? Yeah, can I erase this one? Okay. All right. So, this is what I want us to do. First of all, I want to think that through right here. This 0.02 moles is our lithium hydroxide, right? Okay. Looking at lithium hydroxide, tell me if I have 0.02 moles of that, how many moles of just lithium do I have? Can everybody do that in their head? It's the same amount, right? So we have 0.02 moles of lithium. Okay? How many moles of hydroxide would we have? Everybody see why? Okay. Let's do the same thing here. Yeah, it's all 1 to 1. Okay. So, here, this is 0.02 moles of aluminum chloride. So, how many moles of just aluminum ion would we have in there? 0.02. How many moles of just chloride ion would we have?
0.06.
Does everybody see 0.06?
Yeah.
Because one of these aluminum chlorides, when it gets in water, does it stay together as aluminum chloride? No, it's going to break up into 1 aluminum and 3 chloride ions. And they're all going to float around. Okay? All right. So that's real important to kind of think about. And I kind of like, this is kind of a different way than we approached the problem yesterday, but I think it's going to end up being more clear when we get to each ion. Okay? So you might want to write this down as a model. It just, I don't know. To me, I thought it stayed a little more organized quicker. Okay, now what I'm going to do is I'm going to write the ionic equation. Okay? Does everything break up?
No.
Which one won't break up? The AlOH3. Okay, so here I've got 3 lithiums, 3 hydroxides, 1 aluminum, 3 chlorides, yielding 3 lithiums, 3 chlorides, and 1 aluminum hydroxide. Okay? And if I wanted to write my net ionic equation, let me ask first, what would cancel out? The lithiums cancel and the chlorides cancel. Okay? So what is left is the hydroxide ions and the aluminum ions precipitating to form the aluminum hydroxide. Okay? Have the lithium and the chloride ions jumped out of the beaker? No. They're still in there, they're just hanging out, watching, right? Doing nothing, not getting changed. Okay? All right, so the first concentration that I ask you to figure out is lithium. Okay? Here's the question. What do we do to lithium in the net ionic equation?
Cross it out.
We cross it out. What does that mean?
It's not reactive.
It doesn't change. It doesn't react, it doesn't change. So, if it doesn't change, how much lithium ion do we have? 0.02 moles. Okay? Now, in question, I think we're on question 3. In question 3, I don't just ask you for moles of lithium, I ask you for molarity, right? Molarity is moles per liter you guys just told me that the number of moles of lithium is 0.02 moles. Okay? Now, be careful. How many liters in the end is it floating around in?
0.04.
This is very, very important that you get that these two solutions have been poured together. So you had 20 mils plus 20 mils. You have a total of 40 milliliters. Okay? Don't forget that. So this lithium is floating around in all 40 milliliters. So we're going to divide by 0.04 liters. Okay? Does the green show up, Hala?
Yeah.
Okay. So now we should be able to do this in our head. 0.02 over 0.04 is the same as 2 over 4, which is what? 0.5. So 0.5 molar is actually the concentration of our lithium. How do you guys feel about that?
Gone.
Good? Okay. And another way to talk about molarity, remember you could put lithium in a bracket, that means molarity of, right? Would be 5 molar. Okay. All right. So now we're ready for number 4, hydroxide. Now, let's look at hydroxide. Was it a spectator ion? No. That means it made a change, right? So it's not quite as easy. Well, maybe. Okay, but so here's hydroxide. It gets changed. First of all, I want you to understand that what the question is asking for is it's asking for the OH minus that are free, not any of the OH that is stuck in the aluminum hydroxide. So can you see by the way it's phrased that I'm talking about just the OH? Okay, so let's find the OH and let's think about how much we had. We had 0.02 moles. What do we know about lithium hydroxide? What was question number 1?
Limiting reactant.
That's right. This is the limiting reactant. And what happens to the lithium, to the limiting reactant? It gets all used up. So, how much hydroxide do we have at the end? And you know what? I don't even know how to do a calculation to show it. I would say because LiOH is the limiting reactant, right? And OH negative is precipitated in AlOH3. OH negative concentration is 0. That's what I would say. You just reason through it.
Do you not know how to knock? It's me, I'm a senior.
Okay. Does everybody get that? And so it's real. So we're really moving to not just being ruled by the math, but really understanding what's going on and using it as a tool. Yeah.
I understand that, but if that's true, then why isn't the lithium 0 also?
Okay. Good question. Let's go back. Is lithium in the net ionic equation?
No.
So it didn't participate. Okay? It was a spectator ion. That's why. Okay? All right. So now we're on to aluminum. Now, aluminum is a little bit funky. Is aluminum part of the limiting reactant? No. So aluminum is part of the excess reactant. Is aluminum involved in our precipitate?
Yeah.
Yes. So actually, this is the hardest ion, in my opinion, to calculate because some of it changed and became bound in the precipitate, and some of it is excess still floating around. So, what's our strategy?
Find how much was reacted.
Find how much was reacted and then do what with it?
Subtract it.
Subtract from what we started with. Okay? So, now, if we're going to figure out how much reacted, what do we start with? The limiting reactant. The limiting reactant is the one that's going to run out and determine how much stuff is made. We can't make any more, because once the limiting reactant is gone, the reaction stops. Okay? Now, we actually already, no, we didn't do it. Yeah, we did.
Yeah, you did. It's
Okay, so right over here, do you see that we have our limiting reactant, 0.02 moles of lithium hydroxide. Every 3 moles of that
Yeah, 1 mole.
produces 1 mole of AlOH3. Right, and 1 mole of AlOH3 required 1 mole of the aluminum ion. Does that make sense?
Yes.
Okay, so that is 0.0067 moles of the aluminum ion got precipitated. I don't know how good English that is, but it'll work.
What's
Precipitated. That was hard. Okay, all right. Okay, so if that got precipitated, do I need to slow down for a second? No? Okay, all right. How much did we start with? Okay, we started with 0.02 moles of Al3 plus. We precipitated 0.0067. And so how much is left over?
Divide by.
Yep, we still got one more step left over. So everybody understands how we got the moles, right? And then last but not least, concentration is going to be moles per liter. Our moles are 0.0133, and our volume is what? 0.04. And so what's our overall answer? Point what?
Oh,
0.33.
0.33.
0.33 molar. Does that work?
Yeah.
And I was going to look at sig figs, but I did an atrocious job because in the beginning, see how I gave you 20 mils?
Yeah.
How many sig figs is the way I wrote 20 mils? 1. Ball. 1 molar.
Silly Laura.
Silly rabbit. That's right. It's the rabbit who did it. Okay. All right. So everybody gets this one, right? Okay. Last but not least, number 6. What is the concentration of chloride in the final solution? Let's look back. What happened to chloride in our reaction? It was a spectator. It was crossed out. So nothing happened to it. So there's no change. So how much chloride did we start with?
0.06.
Ah, we started with, let me make this a little,
0.06.
yeah, this was, let me make this smaller. This is 0.33. Okay, so we started with 0.06 moles of chloride. What is it floating around in? How many liters? 0.04, okay? And so
1.5.
6 divided by 4 is 1.5 molar. Does everybody understand? It's a lot of work, but we're starting to understand it better, right? Okay. The picture. Let's draw our little beaker. At the very end, what's the first thing? What's the only thing that you'll actually be able to see with your eyes? Yep, the precipitate on the bottom. So there's AlOH3. Now, what do we know is in there? Okay, I love how you guys started with the spectators, right? You know they aren't used up, but you know they're still there. So let's start by writing our spectator ions in there. And then, what are the only other ions that can be in there?
Al.
Al, because it was part of what reactant?
The excess.
The excess. Okay? Why is the hydroxide not in here?
Because it was used up.
It was the limiting reactant. It was used up. What if you had a scenario where you had exactly the right amount of each reactant. Then what would be over here? Just the lithium and the chloride, just the spectator ions, because the other ones were perfectly matched to all go into that precipitate. Okay? How you guys feeling? Better? Okay, good. Tonight, I will definitely post yet another question. I won't be able to, I'm not going to write all this out, but I'll write down the answer so that if you're working, you have something to work toward, okay, if you want more practice. If you want to move on to a mastery level 5, what are you going to do? Make up your own. In fact, we have 11 minutes left. That's so awesome. Pair up, make up a problem, and switch.
What?
Okay. Oh, no, let's do this. Pair up, the two of you make a problem, and then switch with another pair. Okay? Go, 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 go. Do it. Okay?
I caught that.
You did?